we're going to switch to our second topic for review, and we're going to focus on polynomials. But before we get into that, there are quite a few terms that are really important that you're familiar with. So the first one is, what does it mean when we talk about algebra? Because before we started polynomials, a lot of your math was just based on using numerical values. So algebra is a branch of math that uses symbols to represent unknown numbers or quantities. So algebra is when you start to see what people think of like random letters in their math. Okay, a term. So that's going to be a number or a variable or the product of numbers and variables. And as a reminder, I'll point out when we talk about a variable, sometimes it's easier to think of it as that's your letter. So that's when you might have like an X or a Y, etc. So you'll notice there's a couple examples. So I could just have a number -3, that's considered a term. 5, that's considered a term. Also good to know the special name, if you were to have a -3 or a 5, sometimes if it's part of an expression, this part's going to be called the constant. And then, for example, you could have a term made up of a numerical value and a letter. So the number 2, variable x. You can have decimals, you can have negatives, and you can also have exponents. Right, so I mentioned that our unit, the new unit, okay. So I mentioned that the new topic is on polynomials. So probably a good idea to actually define what a polynomial means. So we're going to go with, it's an algebraic expression made up of terms connected by the operations of addition or subtraction. All right, so you'll notice I listed a whole bunch of examples there. And I do want to point out, so the first two, like if you had the number 2 or like 2 times x, you're going to notice there's no addition or subtraction, and that's okay. These still are considered polynomials, and there's a special name that we'll look at next. Okay, so this is a polynomial, this would be a polynomial. You'll notice now there's a plus sign. This is a polynomial, there's a plus and a minus. This is also a polynomial, there's a plus, there's a minus, there's another plus. All right, so then in this unit, what we did is we focused on how you add, subtract polynomials and how you multiply and divide polynomials. All right, well, there's special names for some of the polynomials. So if you had a polynomial with one term, we would call that a monomial. Okay, so mono means one. So for example, you could just have the number -3, just the number 2, that's considered a monomial, it's one term. You could have 5 times x, that's a monomial. You could have -7y to the power 2, that's a monomial. So the key thing is you'll notice there's no plus or minus after the first term that you have. Okay, so you only have one term. Binomial, bino means 2. Okay, so that's a polynomial with 2 terms. You'll notice there's a plus sign, term 1, term 2. This one has a minus, term 1, term 2. This one has a plus, term 1, term 2. And then the next type, special name, if you have 3 terms, we call it a trinomial. So tri implies 3. So here, notice there's 1 term, 2 terms, 3 terms, 1 term, 2 terms, 3 terms. Beyond that, like if you had 4 terms or 5 terms, 6 terms, 7 terms, etc., there are special names for it, but in grade 9, we just kind of say anything above 3 terms, we just refer to it as a polynomial. So I'll make a note of that. So there's my note, just tells you in grade 9, we call anything with more than 3 terms just a polynomial. And I'm missing an L, there we go. Okay, so again, in grade 10, 11, 12, you'll start to look at the special names. If you're interested, if you have 4 terms, it's called a quartic. 5 terms is a quintic. But for now, we just say more than 3 terms, we just refer to it as a polynomial. Okay, really important that you understand degree of a term. So it tells you it is the sum of the exponents on the variables in a single term. Okay, well, remember, sum means you're going to be adding. So a couple examples here. If I have -3, okay, you'll notice by definition it talked about the sum of the exponents on the variables. So a little bit tricky, -3 doesn't even have a variable. Technically, we could have said it was like some variable with a 0 exponent, but if you remember, anything to the power of 0 besides 0 would always give you a value of 1. So we wouldn't need to write this, but what happens if you have a constant, so -3, we actually say that this is 0 power. So 0 degree. Okay, so any constant will have a degree of 0 because there is no variable there. Doesn't exist. All right, the 5x. Okay, well this time I have a variable and I'm going to look. There's no number here, but keep in mind it's like there's a 1 here. So we would say that this is a degree of 1. You can also call it like first degree if you want. Okay, reason for that, there's only one variable and its exponent or its power is a 1. So we say degree of 1. The next example here, there's a variable. I'm going to look, its exponent is a 2. So we would say this has a degree of 2, or some people like to say second degree. Okay, and then last example, you'll notice there's two variables going on. Not a big deal, it's still one term, right? There's no plus or minus between any of these. So what happens is you actually add the exponents. So you take the 2 from the variable x, and you add it to the 2 from the variable y, and you would actually say that this term has a degree of 4. Or some people would say it's fourth degree. Okay, so key takeaway, if you have a constant, so if there is no variable, that's considered 0 degree. If you have a variable and there's no number there, right, don't forget that implies a 1, so we call that first degree. If you have a number, you just say that's the degree. But then if you have multiple variables, you have to add those exponents together. Next important piece, what is the degree of a polynomial? Okay, so this is different than what I just talked about. Above here, this was degree of a single term. Okay, so that's one term, one term, one term, one term. Well, what happens if you have multiple terms, right? So this has 2 terms, this has 3 terms. How do you figure out its degree? So by definition, we say it's going to be the degree of the highest degree terms in a polynomial. So what happens, you have to find the degree of each of these first. Okay, so I'm going to say that this, remember it's to power 1 technically. So I would say this is degree 1. This is a constant, there's no variable, so technically this would be considered degree 0. So then what the definition says is it has to be the highest degree of the terms in the polynomial. So what I'm going to do is I'm going to look. So degree 1 is obviously higher than degree 0. So then by definition we would say, so I'll use my little therefore, this would be considered degree 1. And again, you can say first degree. Okay, so this binomial, it's binomial because there's 2 terms, I would actually say has a degree of 1. Second example, again, there's 3 terms. So I'm going to look at degree of this term first. The exponent's a 2, so this has degree 2. This term, the exponent's not there, it actually implies a 1. So this is degree 1. This term is a constant, there's no variable, so constant always, always, always has degree 0. And then again, so there's second degree, first degree, 0 degree. You have to take the highest. So then we would say that this polynomial, okay, would technically be degree 2. And some people like to say second degree. All right, so this trinomial, it's got 3 terms. We would say is actually degree 2. All right, so these 2 pieces here, degree of a term, degree of a polynomial, really, really, really important. So if you're unsure about either of these, please send me a quick email and I will help you with some additional examples. Okay, because it's really, really important to know as we head on to the grade 10 math. All right, a couple more things. We are also going to have to know what like terms are. So by definition, those are terms that have the same variable or variables, could have multiple, and they have to be raised to the same exponent or exponents. So there's a bunch of pairs I have here. All right, so you'll notice I have a 3 and a 5. Well, these are just constants, so they're considered like terms. So these are like. The next pair I have, both of them have a variable of x, so it looks pretty good. but then you have to also check the exponent. So this technically is exponent of 1. You don't have to write this. This also would be exponent of 1. You wouldn't have to write that. So these would be considered like terms. Next pair, so this has an x, this has an x, looks pretty good. This is to the power of 2, this is to the power of 2, so I'm allowed to consider these like, so they would be like terms. But look at the last pair. So this has an x, this has an x, looks pretty good, but then you'll notice this has a 2 where this has a 1. So these are not considered like terms. And then the point of us identifying if they're like, what we're allowed to do, well, I know, especially with 3 and 5, if I were to add these, I could go 3 plus 5, I would be able to say, oh, I have 8. Or here, if I have an x, which is like a 1x, and then I have another 3 x's, if I combine them, I could go 1 plus 3 and get, for example, 4x. Here, if I combine these, I would have a 2x squared, but then I'm trying to like subtract negative 5x squareds. So think about that's like you have 2, you're trying to take away 5. If I combine those, I would end up with negative 3x squareds. But this, I'm not allowed to combine. So they would just stay as is. And we're going to come back to this, like this adding, combining in the next examples. Very last piece. Distributive property, another really, really important concept for you to be comfortable with. The rule is super wordy, but basically says it's a rule that states that A times some B plus C will give you AB plus AC. So remember what happens. I always say if there's something in front of brackets, okay, so whether it is a number, it could be positive, negative, could be a decimal, could be a fraction, could have variables, you have to remember it gets distributed. So it's like this A gets multiplied by the B. So that's how I get like the AB. But then the A also gets multiplied by the C. So that's how I get the AC. Okay, it can be, sometimes it's still confusing when it's random letters. So let's do a number example. If I had like negative 3 and I was multiplying it by, let's say 2 plus 5. Obviously, yes, you could go 2 plus 5 first, but let's just practice the rule. It just means that this negative 3 gets multiplied by the 2. So I would get negative 6. And then I'd go negative 3 times positive 5 to get negative 15. And then obviously you could clean that up. All right, example 1. We're going to try and complete this chart. So you're going to notice that it asks about looking at, given an expression, you're going to talk about how many terms you have. We're going to try and use the special name for it. So if it has one term, we're going to say it's monomial. If it's 2 terms, you need binomial. So here, this is 1 term, 2 terms, 3 terms. And then by definition, like all of these are technically polynomials, but we're going to just call it a polynomial if it has more than 3 terms. So let's say 4, 5, 6, etc. Then we're going to look at degree of each term and then degree of the polynomial. So first one, we just have a number 5. So that's just a constant. Well, clearly there is one term. There's only one term, so it's going to be a mono. And I'm just going to put mono. Degree of each term, there is only one term. So I'm going to show, so the term is 5, and it is degree 0. And then if you only have one term, and if its highest degree is 0, then technically the whole polynomial would also be degree 0. Next one, so you have negative 6 times x. Number of terms, still there's no plus or minus here, so it's still one term, which means we call this a monomial. Degree of each term, there's only one term, so I have this. I'm going to focus on what's up here. So keep in mind, it's like there's an imaginary 1, you don't have to write it. So this would be degree 1. And then it's only a monomial, so whatever that degree is has to match. So we would say that polynomial is also considered degree 1. Okay, we have 2x minus 3. So there's suddenly one term, and there's a plus or minus here. This one is a minus. So that means we have 2 terms, right? Term 1, term 2. If there's 2 terms, we're going to call it a binomial. And then the degree of each term, so the 2x, this has a 1, so this is first degree, so I'll put degree 1. The minus 3, so always take whatever the sign is for the second term. So minus 3 is a constant, so it is degree 0. for degree of the polynomial, it has to always be the highest. So we would say that this would be degree 1. Okay, the next one, I will just fill it all in, and then I'll show you my answers. Okay, so for the next one, 2 terms. This is your first term, this is your second term, which means it's binomial. Then the first term, highest power is a 2, so it's second degree. The second term, there's no number there. Keep in mind that means there's a 1, so it's degree 1. But in terms of degree of this polynomial, you have to take the highest, so we would call it a second degree polynomial. Okay, next one, we would say there are 1, 2, 3 terms, which makes this a trinomial. And then I'll list the degrees. So this one is degree 2, this is degree 1, this doesn't have a variable, so it's degree 0. All right, so I've listed, so this 2y squared is degree 2, highest exponent for the y is 2 there. This minus 4y is degree 1, remember that imaginary 1. And then the third term, the 6, there is no variable, so by default it's always degree 0. So for this whole polynomial, you have to look at the highest, that would be this one. We would say that the polynomial is degree 2. And then very last one for the chart, so I'm going to count. So there is 1, 2, 3, 4 terms. So this is 4 terms. Okay, so it's not a monomial, not a binomial, not a trinomial. So for now, we will just call it a polynomial. And then I'll list all the degrees. So this time, if you look, this first term just has a w, the highest exponent is 2, so it's degree 2. But then a bit different here, the second term is 2wy. Well, don't forget, so there's a 1 here, a 1 here. These actually get added together for the degree. So this is also degree 2. And then the y to the power 2 is degree 2. The 8 is just degree 0. So if I look, it has to be the highest degree. So 0, 2, 2, 2. Doesn't matter which one I highlight. They're all the same with those other 3 terms. And I would say that this is degree 2. Okay, example 2. So it tells you simplify each of the following. So you have 5x minus 3x squared plus 2x minus x squared. So what it's asking you to do is you're looking for like terms. So it's saying simplify here. So you're trying to combine like terms. So remember, like terms have to have the same variable, or variables could have multiple, and they have to have the same exponents. So if I have an x squared on one term, I have to have an x squared on the other term. If I had an xy on one term, I have to have an xy on the other term. So what I like to do is I just start left to right. Okay, so I'm going to identify I have a 5x here. I'm going to check if there's another just x term. So I notice, oh, I also have a 2x there. So what I'm allowed to do, and I'll show the work on the side, but I'm going to go 5x plus 2x. Okay, well, you're going to look at the coefficients. So I'm going to go 5 plus 2 is going to give me 7x. And if you think about this, it makes sense. Let's say you had like, I don't know, 5 donuts, and then you're adding 2 more donuts. Well, you know, if you had 5 and you added 2, you would then have 7 donuts total. Okay, so you don't do anything with the variable just stays, but you add or subtract the coefficients. So maybe I'll make a note of that. So when you combine like terms, up here, you're going to add, subtract the coefficients. So remember, coefficients are the numbers in front of the variable. Okay, so my 5x plus 2x becomes 7x. And I'll keep it with a little box. Then I'd go back. So then I have a minus 3x squared. So I have an x squared term here. I only have one term left. I also have an x squared term here. So again, maybe to start off, I'll do the work on the side. So I have minus 3x squared. I'm subtracting another x squared. Okay, well, first of all, I know the x squared has to stay. This cannot magically become something else. Then I'm going to look. I have minus 3, and I'm minusing. Okay, there's no number here. Remember that implies there's a 1. So I'm going minus 3. I'm subtracting 1. It's getting more negative. That will tell me that I have negative 4x squareds. So then minus 4x squareds. Okay, now that's kind of funny to leave your answer like that. So once you get comfortable with this, it's like you have 7x minus 4x squared. Okay, so most of you would probably go from here straight to here. But one last thing too is you want to get in the habit of making sure your answer is in decreasing order of your x. So if I have an x of 1 here and x squared here, I want to switch it. Okay, so we want to try and write our answers decreasing order of your x. So negative 4x squared and then plus 7x would be the answer that I want you guys to work towards. Okay, question B. So again, work left to right. So I have 2x here. I have a minus 2x here. So maybe on the side, 2x minus 2x is going to give me, okay, the x can't disappear, it's got to stay. Then I go 2 minus 2. Well, that actually gives me 0. Well, 0 times anything is just 0. So kind of neat. These actually cancel each other out. And then you have a minus 6 and a plus 1. So minus 6 plus 1, I will get minus 5. So this whole thing actually cleans up and simplifies to minus 5. And that's it. You'll notice, right, I use squares up here, circles, then I use squiggles. You can use triangles, happy faces, whatever makes sense to you. Some of you might not have to identify the like terms and can go straight to the answer, and that's fine too. Okay, last one with this type. So I have a k here. So look for more k's. These are not like terms, right? It's not k squared, just k. So no good, no good, no good. Oh, this one matches up. So it's like I have k minus 3k supposed to equal, well, I know the k has to stay. And then remember, it's like there's a 1 here. So when 1 minus 3, I would have minus 2k's. So these two clean up to minus 2k. Then I have k squared. So minus 2k squared plus 5k squared. So minus 2k squared plus 5k squared. The k squared has to stay. So then worry about the coefficients. So minus 2 plus 5 is going to give you 3k squareds. So plus 3k squared. And then plus 3 minus 4. So 3 minus 4 will give you negative 1. So I have a negative 1 here. Okay, double check. I'm going to get rid of my rectangles, circles, lines. You want to have it in decreasing order of x. So I would say it's 3k squared minus 2k minus 1. Okay, next example, we are going to look at adding polynomials. So these ones tell you add each of the following. And you'll notice the difference is there's brackets. So compared to up here, right, there were no brackets, and then now there are brackets. Only reason for that is you're basically saying like you have some binomial, two terms, you're adding another binomial. Okay, or this one, you have a binomial, you're adding a trinomial. Now, if you're adding polynomials, what you're allowed to do is just drop the brackets right away. So I'm going to rewrite this. This is like me trying to figure out 3x minus 4 plus 2x plus 5. Okay, so now you'll notice that this version looks like the types of questions we just finished up, right? So look for like terms. I have a 3x and a 2x. So I'm going to go 3 plus 2 will give me 5x. And then I have a minus 4 plus 5. Minus 4 plus 5 will give me plus 1. Double check your order. You're good. There's our final answer. So you'll notice on this one, I didn't show my work on the side. If you like that, right? So back up here, how I showed my work over here. If you like that, feel free to do that on your sheet. Next question, we have a binomial and we're adding a trinomial. Again, there's brackets. Okay, so I have a binomial adding that trinomial. I'm going to drop the brackets. I should point out the reason why I can drop the brackets, the value in front of the brackets, there's nothing here. It's like there's a 1. Okay, so technically nothing's getting applied inside the brackets, which is why I'm allowed to just drop them. So 3t squared minus 5t. Again, check. Okay, technically it's like there's a 1 there, so nothing's going to change here. So I can drop the brackets. Now, when I drop the brackets, I'm going to think about, I'm going to be writing this. So I'm going to go plus minus t squared plus 2t minus 1. Okay, this looks really funny and can get super confusing for students. So what I'm going to think about is if I'm adding this negative, really, I don't need to show plus or minus. I'm just going to write it as it's minus. Okay, look for your like terms. So 3t squared, and I'm going to subtract a t squared off that. So 3 minus 1 will give me 2t squareds. And then I have a minus 5t. I'm adding 2 more t's. So minus 5 plus 2 will give me minus 3t. And then if I look, I just have this little constant hanging out at the end, so minus 1. Double check your order, t squared, t constant, you are good to go. Okay, last one. So what if we subtract polynomials? So question A is asking you to take a binomial and subtract another binomial. Okay, now you have to be careful. I'm going to look at this set of brackets. There's nothing in front, right? So I am allowed to just go 3x minus 4. This set of brackets, though, technically, it's like there's a negative 1 there. So what happens, this negative has to get applied to the 2x. So I would get negative 2x. And it has to get applied to the 3. So I would get minus 3. Okay, so be careful when you're subtracting a polynomial, whether it's 1 term, 2 terms, 3 terms, 4 terms, whatever, this minus sign gets applied to every single term. Okay, so notice it went from a plus 2 to a minus 2, went from a plus 3 to a minus 3. All right, then this looks like the question on the last page. So collect, I have 3 x's. I'm going to subtract 2 x's, so I'm left with 1 x. I don't write the 1 here. If you want to, that's fine. And then minus 4, minus 3, you would have minus 7. Double check your order. It is in order, so that would be your final answer. Question B. So check. You have binomial, you're subtracting a binomial. There's nothing in front here, so you're allowed to just drop the brackets. Nothing happens to the signs. The second one, though, be careful. It's like there's a 1 there, so this gets applied to both terms. So negative times a negative will actually give you a positive x, and then negative times the positive 2 will give you a minus 2. So again, notice what happened. This was negative, it switches to a positive. This was positive, it switches to a negative. That has to happen when you're subtracting a polynomial, okay, and when it's in brackets. Collect your like terms. So I have 2x here. I'm going to add another x. So I'm getting more x's. I have 3x. Then you have minus 3, minus 2. Combine those, you will get negative 5. Last question. So we have trinomial. We are subtracting another trinomial. Check your brackets. There's nothing in front here that needs to be distributed, so nothing will change. So I can drop the first set of brackets, just rewrite what I have inside. The second trinomial, though, you got to be careful. It's like there's a negative 1 here, so this minus gets applied to all 3 terms. Okay, really, really important. So this positive 3, when I multiply it by negative, will become minus 3x squared. This minus 9, when you multiply it by negative, actually will switch to a positive 9. And this positive 4, when you multiply it by that negative, will turn into a negative 4. Okay, so when you subtract a polynomial, all the signs have to change. Positive became negative. Negative became positive. Positive became negative. Then collect like terms. So I have 5x squared minus 3x squared, which will give me 2x squared. And then I have minus 9x plus 9x is like plus 8x. And then plus 7 minus 4 would be plus 3. Double check your order. They are in order. So your final answer would be 2x squared plus 8x plus 3. So what I want you to focus in on now is the practice sheet titled Polynomials 1. And again, please make sure you're checking your solutions as you go along. If you get stuck, fire me an email. And then at the end, you're going to identify how you feel. So good to go. Maybe not quite sure, might need a little bit of extra practice or need some additional support. Other than that, have a wonderful day.